The title of my presentation is Optimizing Nutrient Delivery for Modern Cultivars of Greenhouse-Grown Potted Mums using sub-irrigation and drip irrigation. So work over the past year has involved many people, including this graduate student, Catherine Teeter Wood, who began in January 2021 and scheduled to defend at the end of this semester. Another graduate student, Alina Donitz, did the work previously on manganese and iron, and she assisted Catherine in getting started. David Woolen and Bill McDonald, David Woolen from the U of G and Bill McDonald from Niagara College, were on Catherine's advisory committee. Another graduate student, Ed Flaherty, and my technician, Gordon Hoover, were involved in monitoring and harvested plants. And finally, Jamie Albers and Lou Shank at Shank's Farms and Greenhouses were involved in testing our modified nutrient delivery strategy in a commercial setting. Next slide, then, Laura. Okay, to begin with, I'd just like to remind you what our working hypothesis was, and that is nutrient use efficiency in modern cultivars of greenhouse-grown mums is improved by reducing nutrient supply during vegetative growth in combination with an interrupted supply during reproductive growth without sacrificing plant growth in quality. Next slide, please. This slide summarizes the lowest levels of macronutrients we used in our research and the commercial greenhouse experiments with sub-irrigated mums up to 2021. So that's along the bottom there, 19 to 21, and compares them to levels found in 3 common fertilizers, commercial fertilizers in the top for growing mums. So these low input macro delivery systems were applied during the vegetative phase only, yet the macronutrient status of the diagnostic leaves from the mums was considered acceptable compared to the extension literature. That's OMAF and elsewhere in North America. So this is all this data on the bottom of the trials, just an approximate 50 or 60 to 90% reduction in macronutrient delivery compared to the solutions in the top during vegetative growth, and even higher if we consider the entire crop cycle. Next slide, please, Laura. This slide summarizes the lowest levels of micronutrients we used in our research trials. So that's in yellow at the bottom. And compares that to the levels used in the macronutrient studies. That's U of G and Schenck Farms and Greenhouses, as well as these commercial fertilizers. So as you can see, our compared to this Sonnenfeld solution, this is our research standard. This solution that we're using now for micronutrients is approximately 75% reduction compared to this solution. And so and then compared to these commercial fertilizers, this is even more dramatic reduction. So this is all this data here on parts per billion, by the way. Next slide, please. So that brings you up to scratch on what we've done previously. In the past year, we've completed work on optimizing boron and molybdenum delivery to sub-irrigated mums. And the supplies of macronutrients and other micronutrients that we gave are indicated in blue here. And this is in our can't quite see the bottom of the slide. At least I can't on my picture, but so these are in there. That's good. So this is in these data. These supplies are in the lower range of the levels that I previously tested, and they were decreased in this particular trial. The lowest levels of boron were decreased from approximately 50 to 3 parts per billion, and the same thing for molybdenum. And then the complete nutrient trial was nutrient solution was replaced with water at bud break. Next slide. So 2 cultivars, Milton dark pink and Williamsburg purple, were grown in naturally lit greenhouse during the spring and summer of 2021. That's indicated by the circles, and in winter 22 indicated by the triangles. And although the yields are different in the 2 seasons, there was no effect of boron in the range that we used it on shoot yield. And similar results were found with other reproductive morphological characteristics such as bud inflorescence number and bloom diameter. May I have the next slide, please? Next slide, please. And so I'm not going to bamboozle you with all the data. I'm just going to quickly give you a summary of what it says. But the results, this shows the results of inflorescence development as a function of the time during development along the right-hand axis, and the left-hand axis is the stage of development, and the boron supply is along the x-axis on the bottom. And so I think at a quick glance, you can see in the 2 experiments, there's a pretty uniform development of the flower, regardless of the cultivar and regardless of the boron supply. So and that was a little surprising, but let's go to the next slide. But we did see some symptoms of boron deficiency. So as you see at the lowest concentration of boron, 3.38 parts per billion, we found this, what's known as petal quilling. And there's also some evidence of petal quilling at the next highest level, or the next lowest level, at 6.75 parts per billion. Next slide, please, Laura. Analysis of the diagnostic leaf, which is typically the 6th leaf from the apex, is revealed that the leaf boron was clearly deficient at the lowest level. That's down around 10 ppms of boron in the leaf. And the next level is about 20. That's close to what we typically would think as the sufficiency zone for boron. And so these findings suggest that the boron use efficiency was improved with decreasing boron. So you can see if we go from the approximately 50 down to, what do I have, about 14 here, you have a straight line. That's the boron supply, and that's all it maintains a leaf boron at around 47 parts per million. So that's clearly in the sufficiency range. And so with decreasing supply, you expect the boron use efficiency has gone up, and it clearly has. So in order to confirm that, could I have the next slide, please? We determined the total nutrient accumulation by the shoot, allowing us to calculate what I call the various indices for use efficiency. So we'll just focus on 2 of these, and this is the center panel is what I call utilization efficiency, and the right panel is called the uptake efficiency. And I have the definitions underneath here. Utilization efficiency is the milligrams of dry matter divided by the shoot boron, and the uptake efficiency is the shoot boron content divided by the supply. So as you can see, the utilization efficiency changed very little, although it was significant over the supply, whereas the boron uptake efficiency on the right-hand side changed very dramatically over the range of boron supply. So this clearly shows that the uptake efficiency is the primary mechanism for sustaining growth. And this suggests that the root is functioning better, and that's probably due to a higher number of transporters for taking up boron from the soil. Next slide, please, Laura. So we did similar experiment with molybdenum, and in general, There was also no effect of vegetative and reproductive morphological characteristics by the molybdenum supply. Here I've shown simply the shoot yield as one example, but the next slide also shows you the inflorescence development, very similar as before. The development is uniform over the various concentrations of molybdenum. Next slide, please, Laura. And there was also no symptoms of molybdenum deficiency over the range that we used. These were the three lowest levels, from 12 parts per billion to 3 parts per billion, and regardless of the cultivar. And the next slide, please, Laura. And so, while we reduced the molybdenum supply by approximately 90%, the leaf molybdenum was only reduced a minor amount, about 25%, but it's still above 1 ppm in the tissue molybdenum. And that is about typically considered to be acceptable. The acceptable ranges for dicots where leaf molybdenum is about 0.1 to 1 ppm. So clearly we're in the adequate range. Next slide, please. And we also determined the accumulation here, so we could calculate the indices. And you can see both of them. Let's focus on the center and the right panels. There are some pretty dramatic increases in the levels and the numbers as we decrease the molybdenum supply. But the data are very variable at the low concentrations. That's in the second experiment. So it's not, there was no significant difference in any of the data in the second experiment. Oh, go back one. But we can at least say that there was about a 1 to 2-fold change in the uptake efficiency and the utilization efficiency over the range of boron supply in the first experiment. Next slide, please. So in September 22, we conducted a sub-irrigation experiment at University of Guelph, where all the macronutrients and micronutrients were decreased by 50% over the low sufficiency range, so that none of the nutrients would be considered or approach deficiency by itself. So for example, with nitrogen, we used 150, 175 ppms of nitrogen. So this is still lower than the industry supply, but it's still and should be in the sufficiency range. So this was fairly easily done because the nutrients were mixed from analytical sources. Next slide, please. And as you can, we used 2 cultivars and conducted 2 trials. And as you can see, the plants look really good. And the shoot yield, I've shown you the shoot yield here on the right-hand side and the shoot height. And there are very minor effects in 2 cases, but they're fairly significant. So we determined the use efficiency here for 2 nutrients. These are 2 mobile nutrients, the nitrogen and phosphorus, nitrogen along the top, phosphorus along the bottom. And we can focus on the middle and the right-hand slides. And in both cases, the uptake efficiency increased much more than the utilization efficiency. And clearly that is a much more important mechanism, even when you're decreasing all the nutrients simultaneously. Next slide, please. And this, okay, so this slide shows the micronutrients, shows similarly, but in this case, I've changed the plot a little bit. I've only shown you 2 from each. So the top panel is the utilization efficiency for manganese, boron, and calcium from left to right. And then the lower panel is the uptake efficiency. And once again, you can see that the slope of the curves are much more dramatic for uptake efficiency. So clearly the roots are functioning much more efficiently when you lower the nutrient supply than the redistribution of nutrients within the plant. Next slide, please, Laura. Okay, so in the fall of 2022, we conducted a drip irrigation experiment at Schenk's farms and greenhouses. In this case, we used 3 micronutrient levels, or macronutrient levels, apologies, at the top, and 4 micronutrient levels at the bottom, so that the respectively, that was 50 and 25% of the highest level supply. But in this case, we used a commercial fertilizer with separate macro and micronutrient bags, so the exact mixture is not as exactly controlled, closely controlled as with the sub-irrigation experiment. Next slide, please. And it was not possible to replicate the experiments because of the size of the benches. As you can see, these are long benches. So we placed 2 technical reps at each end of the bench to get as much of the environmental variability as possible. And we calculated the data results as a mean of 4 technical reps. So it's not possible, again, to statistically analyze the data because there's no treatment replication. But if you look at the figure here, this gives yield. There's clearly there's no obvious or clear effect of treatment on the yield with the 4 different cultivars. Next slide, please. And in this case, I'm not going to go over all this data, but I want to say we did analyze the macro and micronutrients, and we found that in this case here, all the macronutrients were in the acceptable range, even though in some cases the levels dropped as supply dropped, which is what you'd expect. Next slide, please. And this is micronutrients, the same thing. And so let's just skip over that, Laura, but I just want to know we did collect the data. And finally, I just want to wrap it up with the highlights. These next 2 slides will summarize the highlights of actually the 8 years of research in which we've been optimizing this. In both research and commercial settings, we removed the entire nutrient supply at bud break, substantially reducing the supply over the crop cycle. At the university, we did 2 validation experiments. That's what I have U of G sub-irrigation with rigorous experimental design using 2 cultivars, and the amount of fertilizer in the pot medium was minimized by inserting each cutting into a peat jiffy plug, amended with 30% minerals, and using a 50-50 peat perlite mix without a starter charge. At Schenk farms and greenhouses, we did a single validation experiment with drip irrigation. The experimental design was less rigorous because the nutrient treatments were not replicated. Also, we used, as I say, drip irrigation instead of sub-irrigation, and we used 4 cultivars. The jiffy plug was omitted, and specifically formulated premixed fertilizer sources were added to the pot. So a further reduction in the liquid fertilizers may be possible. Nevertheless, it's clear from both these sub-irrigation or drip irrigation studies that the macronutrient supplies in the liquid fertilizers can be markedly reduced during the vegetative phase compared to the typical fertilizer, commercial fertilizers, without adversely affecting plant and flower quality. So see these are down around 25% of the levels in the commercial fertilizers. Similarly, the next slide, we have the micronutrients were reduced dramatically compared to the commercial fertilizers. Just some final comments. Next slide, Laura. Overall, our project indicates it's possible to interrupt the nutrient supply at bud break with both sub-irrigated and drip irrigated mums without affecting plant flower quality. And it's possible to further reduce the nutrient supply during vegetative growth. And this modified delivery system reduces the fertilizer use and the cost, as well as creates a smaller volume of nutrient-rich feed water that must be treated and or discharged. We believe this strategy can be applied to other floriculture crops and possibly edible greenhouse crops. And I expect that in the near future, we'll probably see some new fertilizer formulations to take advantage of this research. Next slide, please, Laura. Okay, in the past year, we published one scientific paper in Canadian Journal of Plant Science, one article in Greenhouse Canada magazine, one article in Floral Daily resulting from an interview with Rita Württemberg, and the final graduate student is expected to graduate in March. We are anticipating 2 more scientific papers, giving us a total of 8, and at least 1 more article in the industry magazine, also giving us a total of 8 in combination with 4 graduate students being completed over the 8 years we've been funded by COHA. So that's the end of the, one more, I think. I should tell you who funded the research. This is funded by the Accelerating Green Plant Innovation for Environmental Economic Benefit Cluster, and it's funded by COHA, the Government of Canada, under the Canadian Agricultural Partnerships Agri-Science Program. Our industry partners were Shank Farms and Greenhouses and AgMedica Bioscience of Chatham. So thank you very much. I'm happy to take questions.
All right, wonderful. Thanks, Barry. I will open the floor now. I don't see any questions in the chat or in the participant list, but if anybody has any questions, please, now's your time. Now's your chance to ask them. Just speak up if you'd like.
Apologies for, there's a lot of data there, I know, but I'll get a chance to look at it again if they're enthusiastic, and you can certainly get back to me and we can discuss it further.
Absolutely. I should have some questions for you, Barry. We're just working behind the scenes. Some of the folks can't seem to get into the webinar, so I've been sort of
okay, no problem.
Trying to figure that out. But I do see one question from Rose, and Rose, go ahead.
Okay. Yes, so Barry, very nice, and I think our 2 projects complement each other very well, as you will see when I present my results. But I was just wondering, these fertilizer reductions that you see, can they be achieved by just lowering the complete recipe, just using a lower rate, or do you have to adjust each individual nutrient separately?
No, and that's why we did the trial at Shanks. That's essentially what we did. We just diluted the commercial fertilizer, 75%, 50%, and 25%. And, it worked out just fine. It's just it was not the optimal ratio. You just take what you're getting, and you're still getting, we didn't see any adverse effects. Initially, I was anticipating maybe some competition effects, as you often see in the literature. People, when the nutrients get out of ratios, particularly with the micronutrients, some of the micronutrients are taken up by the same carriers. But when you're working with, I think, low sufficiency levels, there's never an issue with competition or antagonistic or synergistic effects. So I think a lot of the literature effects in the scientific literature are seen because people are looking at high levels, excessive levels. So yes, your strategy is a good one. It's simple. Perhaps we should have started there, 5 years ago. But we were focusing on nitrogen when we started because that's the one that was the most serious issue. Does that answer? Okay.
I was muted there. Are there any other questions from anyone on the call?
I should just say, Rose, we were trying to do some physiology along with this as well. So you can see looking at uptake and all the initial experiments we did nutrient budgets, which are very time consuming. And we focused on the model system, remember, with the single stem plants. And as we found that was no longer necessary. So towards the end, we were able to do things much more quickly by using a system more typical of what the grower uses.
Awesome, thanks.
Okay. Probably taking up my time. I had used a lot up front.
Okay, no worries. We're still on time, Barry, and
Okay.
thank you